Right, the last thing that we're going to talk about in section 10.2 is we're going to talk about simplifying polynomials. Right? Again, we've actually already done this. Right? We talked about this in section 8.7, so there's a few notes from section 8.7 that we're going to refer back to. Because when we're simplifying polynomials, we are simply combining like terms. Right? So to simplify polynomials, we are going to combine like terms. Right? So as we're going through and we're combining these like terms, remember like terms are the same variables raised to the same exponents. The variables don't necessarily need to be in the same order because of our commutative property of multiplication. Our variables don't necessarily need to have the same coefficients. Right? We just want their variable pieces to match up. When we're combining like terms, what we're using are the numerical coefficients out front, and then we're going to multiply that result by the variable factor. In this case, unlike what we did in the last section, our exponents should not change. Right? So we're just combining like terms, we're just using our coefficients out front. Our exponents are not changing as we're simplifying polynomials. Okay. So let's go through some examples. So we're told to simplify, combine like terms if possible, write the simplified polynomial in descending order. Okay. So what that means if we're asked to write our polynomial in descending order, we generally look for the terms that have the largest exponents first. Okay. So in this case, my variable terms with the largest exponents are these two x cubed terms. Right? 8x cubed plus 2x cubed is going to give us 10x cubed. Right? And then we have a numerical term of -5. So our final answer here is 10x cubed minus 5. Right, for B, right, we have 6y squared and -10y squared. They are like terms. They're going to combine to give us -4y squared. Right, different signs, so we subtract and we keep the sign of the negative because that is our larger number. Right? Our plus 3y is going to turn into our second term in exponential order that's descending. We have a 6m squared and a -9m squared. That's going to give us a -3m squared. We have a -3k and a positive 5k. Different signs, so we subtract. This time we get a positive number, so we have a positive 2k. And then we have a constant term, a number-only term of plus 2. Right, for D, we have a -3x squared and a positive 2x squared. Different signs, so we subtract. We get -1x squared. It's up to you. You can write that 1 in there, or you could just leave it out. We could also write just a -x squared. Right? Either of those would be fine. Right, we have a positive 4x and a -4x. These are just going to cancel each other out. We have a -8 and a -5. Same sign, so we add. Right. So we have two alternate ways of writing our answer. We could write it as -1x squared minus 13, or we could drop that invisible 1 as a coefficient and write -x squared minus 13. Either one would be a correct answer. Okay. All right, two more to go through. All right. Our highest degree term is x to the 5th. A positive x to the 5th and a -4x to the 5th is going to give us a -3x to the 5th. Right. A -2x to the 3rd and a positive 7x to the 3rd. Just like the last two, different signs, so we subtract. This time we have a positive 5x to the 3rd. And then our last term here is just a -x. And then to finish it off, looking here, we have two different variables. Technically, our -6ab and our 5ab are the highest degree terms that we have. With two different variables, descending exponential order gets a little bit trickier in some cases, but for us for now, this'll work. We'll start with our terms that has both the a and the b in it. Negative 6ab, positive 5ab, same sign, or excuse me, not same signs, different signs, so we subtract. Negative 6, positive 5 is going to give us a negative 1. Right? So we're going to have negative 1ab, or we can just drop that negative 1 like we saw in the previous example and just write negative ab. We tend to try to drop those negative ones if possible, just that way we really are in simplest form. However, if you do write them in there, it's also still correct. Then we're going to go just in alphabetical order. So a 7a and a negative 3a, different signs, so we subtract, is going to give us a positive 4a. And then we finish it off with our negative 4b term. Right? So again, combining like terms is something that we've done before. Right? We're just using our numerical coefficients out front. Right? We're not changing our exponents. The only thing that we've added is when we write our answers, we generally want to write our terms with the highest exponents first, and then work our way through until we get, if we do have just a numeric term that does not have a variable, that's going to be the last term. As we're going through the next few sections, adding and subtracting polynomials, we're going to use this idea of combining like terms in every single problem that we're going to be doing. We're going to be using it in some of the multiplication problems that we're also going to see in section 10.4 as well.